Okay, this is a continuation of the Math 1113 Zoom meeting for Tuesday, February 2nd. This is part 2. 13, part 2, Zoom meeting. Just to let you know, just show again, this was the first homework problem in 5.2, I'm sorry, 5.2. This was the first homework problem, and it was about, this is the picture of the triangle in the book, the angle's in that position. And so you got the adjacent side here, the opposite side here. And again, all of these numbers obey the Pythagorean theorem. I'm just pointing this out because they're right triangles, they have to. They don't just make them up willy-nilly. And so they want you to write down all 6 trig ratios and sine opposite over hypotenuse, 4/5, cosine adjacent over hypotenuse, 3/5, tangent opposite over adjacent, 4/3. The other 3 ratios are the flips of these. Okay, need to go on and we need to show special angles. What is special about 45 degrees? We'll do 45 degrees first, 30 degrees, and 60 degrees, 45. All right, so 45 degrees. If you understand what is special and what occurs with the legs at these angles, you understand probably 90% of trigonometry. Okay, let's look at 45 degrees. Start out here at 0 and you're swinging a ray up to 90 degrees. Okay, at each point you stop, you can form your Y leg and your X leg. Do you see this is less than 90, less than 45 degrees? And you see what happens? I can keep increasing it and increasing it. And can you see your X leg gets shorter? Y leg increases. But your Y leg is less than your X leg below 45 degrees. You see, you can see, can you see your Y leg is smaller than your X leg below 45. So then you swing, let's put 45 right here. Now you're greater than 45 degrees, and can you see that your Y leg is greater than your X leg for angle greater than 45 degrees? So can you tell what happens at 45 degrees? This is the angle where your Y leg equals your X leg. X equals Y. Okay. The Pythagorean theorem says that your X leg squared plus your Y leg squared has to equal your R squared, and we're making R equal 1. So X squared plus Y squared, 1. These are all right triangles. Set Y equals X at 45 degrees. And you can have X squared plus X squared equals 1. That means 2X squared equals 1. That means X squared equals 1/2. And X equals the square root of 1/2. We're using only positive here. That means x equals 1 over the square root of 2, and that's legal, but they like it rationalized. So square root of 2, that means get the root out of the bottom, and your top is square root of 2 over 2. This equals 2. And this equals your y leg. This means at 45 degrees, your x leg is square root of 2 over 2. Your y leg is square root of 2 over 2. And this is the coordinates. The xy coordinate here is root 2 over 2, root 2 over 2 at 45 degrees. The beginning coordinate, remember it's on a circle. The beginning coordinate is 1, 0. The coordinate up here is 0, 1. The coordinate over here is negative 1, 0. Coordinate down here is 0, negative 1. And the coordinate here is root 2 over 2, root 2 over 2. If you want to check it, sub in to x squared plus y squared equals 1. Root 2 over 2 squared, add root 2 over 2 squared equals 1 squared. You would get 2 fourths plus 2 fourths equals 1. You can go 1/2 plus 1/2 equals 1. 2 fourths is a half in each case. And sure enough, it subs in. Now, this is your first quadrant. Remember, there are equivalents in the other quadrants. So if you come over here at 135 degrees, you've got 45 each side. That would put the x leg negative, the y leg positive, meaning this would be negative root 2 over 2, positive root 2 over 2. You're just keeping the exact same angles and everything, exact same hypotenuse length. You're just flipping the coordinates around the origin. Come down here, and you're at.
Are you on Zoom?
Yes. They're both negative. And you come down here, and that was at 225 degrees. I'm sure you have all this perfectly memorized. And you come down here, and you're at positive x and negative y in the fourth quadrant at 315 degrees. Now, how do we relate this to sines, cosines, and tangents? Tangents. Okay. Remember, sine, say, of 45 degrees. If I take the sine of 45 degrees, I get opposite over hypotenuse. Hypotenuse is 1. This is opposite. This is adjacent, which means I get opposite root 2 over 2 over hypotenuse, which is 1, meaning root 2 over 2. Turns out the cosine will be the same thing. Cosine of 45 degrees will be root 2 over 2. It's got the exact same length on the leg over hypotenuse of 1, root 2 over 2. Be the exact same thing. And it turns out that the tangent of 45 degrees will equal, again, opposite over adjacent. This was adjacent. You want to see the full definition over hypotenuse. Opposite over adjacent, which would be root 2 over 2 over root 2 over 2. You can see they're equal, so you get 1, or if you want to see the full algebra, over 2 times 2 over root 2. Remember, it all flip around. Remember, you got to flip the bottom. Flip and multiply, and you get 1. Now, to give you some confidence in this, and we're going to be using the calculator a lot, you can check this with the calculator. First, look at your angle. If angle is in degree mode, or is in degrees, use degree mode. If your angle in radians, use radian mode. Okay, so that is in your mode button up here. Third line down, radians versus degrees. So I want to be in degrees. Okay, so if I hit then sine 45, it takes the 45 to be in degrees. Hit enter, and I get this nasty decimal. I'm getting sine of 45 degrees to be 0.7071. Well, up here I said it was root 2 over 2. Root 2 over 2, if I punch it that way, I get 0.7071. The calculator, there are special calculators that would probably tell you root 2 over 2 directly, but these more basic ones do not do that. They give you the decimal equivalents. I can check with a cosine of 45. Same thing. Same thing. The tangent of 45 we said was 1. Sure enough. Tangent 45 degrees equals 1. Now remember, you can be in other angle systems. So remember, this was equal to pi over 4. If I punch, I need to switch it to radian mode. Radian mode. And if I punch sine pi divided by 4, that's equivalent to 45 degrees, 0.7071. Cosine pi divided by 4, 0.70, hit enter and I'll get to 0.7071. 0.7071. Tangent pi divided by 4, 1. Because in radian mode, it's taken pi over 4 to be in radians. If I go to other quadrants, look at 135 degrees. Keep the same picture up. This is 0.7071. This should be negative 0.7071. If I punch, let's go back to degree mode and punch it 135 degrees. So mode, back to degree mode. So if I punch sine 135, there's my positive 0.7071. If I punch cosine 135, negative 0.7071. Notice that this equals my y coordinate at 135 degrees. This equals my x coordinate, 135 degrees. My tangent in 135 should be negative 1, y over x, tangent 135. There's my negative 1. Y over x, sine over cosine. That's one of our first basic formulas. A tangent is always sine divided by cosine. Sine is your direct y coordinate, cosine is your direct x coordinate. Always. Sine of an angle equals y coordinate on the unit circle. Cosine of an angle equals the direct x coordinate on unit circle. Tangent theta is equal to y divided by x, opposite divided by adjacent, is equal to the sine, since y is sine of an angle and x is cosine of an angle, a tangent of an angle is equal to sine divided by cosine. That's one of our first basic formulas. This is called an identity. Identity. Can't spell it. That a tangent of an angle is equal to a sine of the angle divided by the cosine of the angle. Don't even need the tangent button on the calculator. You could do a tangent from going sine divided by cosine. So sine and cosine are the absolute two basic ones. Sine, cosine theta, y leg, y coordinate, x leg, x coordinate are the two basic functions. Every other function can be written in terms of sines and cosines. Absolutely mathematical fact. All right, let's look on to 30 degrees and 60 degrees. $60. What is special? Take an equilateral triangle. Side length 2. Equilateral means all sides equal. Equal 2. Drop a bisector. That will put a 1 here and a 1 here. Right triangle, we'll call this leg U. Pythagorean theorem. U squared plus 1 squared has to equal 2 squared. Leg squared equals hypotenuse squared. U squared plus 1 equals 4. U squared equals 3. U equals square root of 3. This leg will be the square, the vertical leg here will be the square root of 3. My Wi-Fi froze. Please come back. It's been working good. Nope. Guess there's going to be a part 3 to this video. Unless I can get this back. Okay, are we back? Okay, let's hope that kept recording. Hopefully we're back. Sorry, the Wi-Fi quit on me. I hope we're back. Hope the first video took. Okay, so we've shown that vertical leg is root 3. Okay, angles here are all 60 degrees because it's equilateral. Hope you remember that fact, basic geometry. Draw it, 2, 2, 2. Angle A, all the angles have got to be the same. The line is the space across from this other thing. All the angles have to add 280 degrees in a triangle. Basic geometric fact. All angles of any triangle have to add to 180 degrees. 3A equals 180 degrees. So A is 60 degrees. So that puts 60 degrees here. Here, and then this is bisected. That's got to be 30 and 30. Now we're ready to write down, pull this out, and we can say line it up with the coordinate system at 30 degrees. You can see the opposite side is 1, and it's we're using a hypotenuse of 2, and the adjacent side here is root 3. Okay, if I now use basic definition, sine of 30 degrees is opposite over hypotenuse. That makes opposite side a half. This is opposite. This is hypotenuse. That's a half. Okay. Cosine of 30 degrees is equal to adjacent over hypotenuse, root 3 over 2. Tangent of 30 degrees is equal to, once we said sine over cosine, y over x, 1/2 over root 3 over 2, which is 1/2 times 2 over root 3. 1 over root 3, multiply again, rationalize, which is equal to root 3 over 3. All right, once again, I'll give you a check. Make sure we're in degree mode. Yeah. Sine 30, we're not going to get 1/2. We're going to get 0.5, the decimal for 1/2. Cosine 30, we're going to get this decimal, and if I go root 3 over 2, 0.866, same decimal. If I go tangent of 30, we get this decimal. And if I go root 3 over 3, same decimal. Remember, I could punch in radian mode, pi over 6 in radian mode for all of these. Tough to do every single case. But this is my y coordinate at 30 degrees. This is my x coordinate at 30 degrees. So let's put this on the circle. Degrees, y coordinates a half. We can make the unit circle a 1 and make this root 3 over 2. So sine of 30 degrees is 1/2 over 1, which is 1/2. Cosine of 30 degrees, root 3 over 2 over 1, which is root 3 over 2. Making this coordinate root 3 over 2, 1/2. If I go up to 60 degrees, 60 degrees there, 60 degrees there, that puts 30 degrees here. 90 there, 1630 is 90, 90 is your 180. I don't know if you can tell this. You can make the argument, or I can do it again off this 30-degree angle, or I can do it off of this 60-degree right here. Let me redraw that. Vertical side there was root 3, 60 degrees here. Hypotenuse was 2, this side was 1. I just pulled that triangle out. Sine 60 degrees, root 3 over 2. Opposite over hypotenuse. Cosine 60 degrees, adjacent over hypotenuse. So you've swung around and doubled the angle, and in effect, the legs, the Y leg here has become equal to the X leg, and the long leg here has switched and become vertical to the long leg. This is root 3 over 2. This is 1/2. So in effect, the coordinates have switched. 1/2, root 3 over 2. Again, I could go off. This is 60 degrees here. 120 total. And my coordinate would switch to -1/2, positive root 3 over 2. So your Y legs are exactly the same. If I go down to 30 degrees here, be 150 degrees. My X leg is negative root 3 over 2. My Y leg is 1/2. In effect, they've switched. And the X leg is negative in both cases. The Y leg is positive. Third quadrant, 30 degrees. That would be 210 degrees. Your X leg is long, so that's negative root 3 over 2 and -1/2. Down here, your X leg is -1/2 and your Y leg is also negative root 3 over 2. That would have been at 240 degrees. 60 to here, 30, 240 total around. Fourth quadrant, that would be in 30 bigger than 270, 300 degrees. +1/2, negative root 3 over 2. And this direction, positive root 3 over 2, -1/2. That would have been at 330 degrees. I'll just punch one, just show, I'll punch 330. This means the sine 330 is -1/2, which is -0.5. Sine 330, -0.5. This would have been, yeah, 330 degrees, -0.5, the sine. This is the sine, this is the cosine. Okay, that's about the best intro I can give you to all of these different coordinates in plain English. Just to summarize this, LIS in plain English. I'll draw out the 30-degree angle again. 30 degree, get it up here, everybody can see it. 30 degrees, that's 1/2, that's 1. 30 degrees is the special angle where the Y leg is is 1/2, 1/2 the hypotenuse. 60 degrees is the special angle where the X leg is 1/2 the hypotenuse. You can see that up here. At 60 degrees, your X leg's 1/2, hypotenuse is 1. The X leg's 1/2 the hypotenuse. At 45 degrees, the legs are equal. The legs are equal, both root 2 over 2. That's the best summary of the intro to trig that I can give. I sure hope the first part of this Zoom worked. Hope they didn't lose it. I still seem to be recording. I'm going to assume it's working. We'll work some practice problems out of 3-2 then. And this is 5.2, I'm sorry, 5.2 homework practice. Let's see, why don't we try number 9, page 453. They give you it's a right triangle. It's called a beta, alpha, beta, 3, and 5. Now, don't get confused. Maybe I should get rid of that. Okay. That doesn't mean there's a 4 here. Okay. You know, 3, 4. These are on the legs, hypotenuse. Squared will equal 3 squared plus 5 squared. That will be 9 plus 25. Hypotenuse squared. That'll be 34. Hypotenuse squared will be 34. The hypotenuse here is going to be root 34. Sometimes they try to get confuse you. Part A, they want sine alpha. Well, that will be opposite over hypotenuse. Looks like it'll be 3 over root 34. The book, if you check it, may rationalize this. I don't make you do it. I'm very happy if you can write that down. All right. They want cosine beta. That will be adjacent over hypotenuse. Well, that would be 3. See, sine alpha is opposite. Cosine beta will also be 3 over root 34. Yeah, it's the same thing. Because your adjacent sine on the beta is 3 over root 34. So they're equal. Okay, B, tangent alpha and cotangent beta. Tangent alpha, opposite over adjacent, 3/5. Cotangent beta. Tangent beta would be 5/3. Cotangent would also be 3/5. They're equal. 3/5. Cotangent was adjacent over opposite. Secant alpha, I bet these are equal too. Secant alpha is 1 over cosine alpha. I would do the cosine first. Cosine of alpha is adjacent over hypotenuse, would be root 34 over 5. Secant, cosecant beta, sine of beta would be 5 over root 34, so it would be root 34 over 5. Yeah, they're equal. Hopefully 11 to 14 here, you can punch on the calculator. Make sure you're in degree mode. Let me try something like 13a. Secant of 13 degrees. See, there's no secant key. So you'd punch it 1 divided by cosine of 13 degrees in degree mode. Am I in degree mode? Yeah. Divided by cosine 13, 1.0263. It's the inverse of the x-coordinate at 13 degrees. That's what this means. Inverse x-coordinate 13 degrees. All right, now we're going to use this in 15 to find lengths of unknown sides. Page 453, 15. So you have 30 degrees, 25, and X. They want it rounded to 5 places. Okay. Well, you know that's right triangle. You know the opposite hypotenuse. So you'd use a sine. Opposite over hypotenuse is X divided by 25. To solve, multiply by 25, and you'd have X equals 25 sine of 30 degrees. Now, from what I just said, that's a special angle. You should know that's equal to a half. So basically, a half of 25 is going to be 12 and a half. The answer should be 12.5. But we'll punch it out to see. I am in degree mode. Yeah. 25 sine 30 degrees, 12.5. And that is because sine of 30 degrees by itself is a half. Okay, so it's a matter of reading the triangle and using the function you need to do it. All right, you look at 21 and it's a little strange. Looking for my assignment. I think I went through 43. Oh, I think I went through 43. Doggone. I can't find the exact assignment. I think I went through 43. Doggone, where is it? Oh, well. Oh, maybe right here. 5.2, I went through 49, actually. Okay, so I did go through 49. So we'll work through a few more sections of it. Okay, 21. Y, X, and theta. Express X, Y in terms of trig ratios. Theta, they're not really clear on the directions here. Well, notice this is adjacent, this is opposite. You want to do X first, you'd have cosine of theta, adjacent over hypotenuse. Hypotenuse would be X over 28. Multiply both sides by 28. And your X would be 28 cosine of theta. Notice a cosine of an angle gives you an X coordinate. It's the direct X coordinate. This is 1, a unit circle. This in effect is on a circle of radius 28. If I did sine of theta, Y over 28, then Y would equal 28 sine of theta. A sine of an angle gives you a Y coordinate. This happens to be on a circle of radius 28. You can think of it that way. Coefficient is the radius of the circle you're on. All right. How about 23? A lot of different sections in this. Tangent theta, 5 over 6. Find all 5 other ratios. So what you do is you sketch this out. Remember, this would be opposite over adjacent. If that was 6 over 6, you'd be at 45 degrees. See, we're less than 45 degrees. This is where knowing the, very physical, knowing the different lengths and everything is because your Y leg is less than your X leg. You got to be a little less than 45 degrees, but we don't know what the angle is. We'll show you how to find that, but that's coming attractions. But your Y leg, your opposite would be 5. This would be 6. I know that that angle is less than 45 degrees, but that's not super important at the moment. All right, we'll write down the other angles. Ratios, actually these are ratios. I can fill in the tangent. is 5 over 6. I can fill in the cotangent. It just flips 6 over 5. Here's the secant. Here's the cosecant. All right, I need the hypotenuse. Hypotenuse squared, 6 squared plus 5 squared. 36 plus 25. Isn't that going to be 61? Probably shouldn't do that in my head. Hypotenuse is going to be the square root of 61. Maybe I should double check. 36 plus 25, 61. All right. Once I know that, the sine opposite over hypotenuse, 5 over root 61. We won't make you rationalize. The cosine, 6 over root 61. Adjacent over hypotenuse. This is adjacent. This is theta. This is opposite. Cosecant, root 61 over 5. It just flips. Secant, root 61 over 6. You can do the other. I'll let you do the others. We'll have another meeting. Supposed to find expressions without using a calculator. I don't care if you use a calculator. You're fine. You can use a calculator. I'll let y'all mess with that. And then solving a right triangle. Let's try 37. Solve a right triangle means find all missing missing sides and angles. They've kind of twisted a little bit. I can straighten it up. You got 45 degrees. You got 16. If you're really good, you should know that this side is 16. The legs are equal. All right, well, that means this is 45. This was a really simple one. 45 is 90, plus 90 is 180. Don't really have to write. How do we do the hypotenuse? Well, hypotenuse squared plus 16 squared. I think that's 256. 256 plus 256 is, I believe, 512. Multiplied by 2. Yeah, 512 squared. And we'll just send us the square root of 512, which is equal to 512. So it's the square root of 512. I don't think that's anything clean, and we won't simplify it to a square root. I don't believe you're going to get anything. Answer, no, it's just a nasty decimal. And so there you are, you've solved the triangle. Now, that was a simple one. You'll have other ones that are a little tougher. I really didn't, let's see, 3 to 49. I don't know why I did that. I really think you can stop it. You don't have to do 45. We'll cross off 45. Try something like 43. Pi divided by 5, 106. Right angle. All right, I want to solve this. Call this side x, this side hypotenuse. Can't get them. We only know one side, so I can't get either one. Looks like we're going to have to play. We could either play, there can be multiple ways to do these things. We can either play sine and get to the hypotenuse first, or we can play tangent and get to the x first. You can do it either way. Let's go tangent of the pi over 5 is equal to 106 divided by x. Opposite over adjacent. We would then, in effect, can multiply by x and divide by tangent pi over 5. X X cancels, tangent pi over 5. 106 divided by tangent pi over 5. Radian mode. Better check mode. I'm in degree mode. Radian mode. Tangent, come on, 106 divided by tangent, 100 and pi over 5. 145.9, we'll call it. You could use any of the trigs. You could use sine this over this and solve for it. You could use cosine this over this and solve for it. You could use the Pythagorean theorem now. So there's multiple ways to do these things. I guess I'll use a cosine, pi over 5, 145.9 divided by the hypotenuse. So your hypotenuse is going to be 145.9 divided by cosine. That's pi over 5, my fault, pi over 5. We're going to divide that by cosine pi divided by 5. Should be 180.337. We'll call it 338. You can quick check if I just go 145.9 squared, add 106 squared, take a square root. I should come out. We'll come out close. It won't be exact because of Randolph error. Plus 106 squared, take a square root, 180.34. 338, not too bad. Makes perfect sense to me. Okay, I think I'll leave the last little section for y'all. I know this has gotten very long. We have one more Zoom session. We can go over problems in the very last section to 49. So we will go ahead and end this. Appreciate if anybody listened this long. Appreciate it. At least I gave out a thorough intro to problems in the section in my version of a thorough intro to trigonometry and all the angles you need to know and all the special values you need to know. Okay, we'll end the video. Thank you very much. If anybody listened, thank you very much.